Today's lesson is over section 4.3b, solving quadratic equations by factoring. As you'll see in the PowerPoint, how we solve quadratic equations by factoring is we use what is called the zero product property. If you look, it says if a times b equals 0, then either a equals 0, b equals 0, or both a and b equal 0. Back in elementary school, you may have seen something like this, 2 times, and then they gave you an empty box equals 0, and they wanted you to fill in the box. Of course, if the product of 2 and a number is going to be 0, then that value had to be 0. And that's really the premise we're working on when we use the zero product property to solve quadratic equations by factoring. Let's take a look. We're going to do a few examples here, and you'll see how we use this. So I have solve x squared plus 12x plus 35 equals 0. The first thing you always want to do with your quadratic equation is get it in standard form on one side equal to 0. Of course, in number 1, that's already been done for us. So the next step is to try and factor it. Since there are 3 terms and no common factor, I'm going to try reverse a FOIL. So I'm going to put x and x in the first positions, since I know that has a product of x squared, our first term, and then the last positions need to have a product of 35, and because this operation is plus, we need the numbers we pick to add up to 12, since the first positions are both x. So the 2 numbers that would work are 7 and 5. Doesn't matter the order you put them. I do know since it's a positive 35, the signs have to be the same. And in this instance, they're both plus, since the middle term is positive 12x. At this point, you take each factor and set it equal to 0. And then you solve to find what the value would be for x. So x is going to equal either negative 7 or x is going to equal negative 5. And I would expect you to show that step at this stage of the game. Once we get beyond this, then we'll talk about whether we can drop that intermediate step. Let's look at number 2. This time we have 9x squared minus 4 equals 0. Again, we're already in standard form, so I want to look at factoring. There is no common factor, but there are 2 terms, and there's only one rule at this point that has 2 terms, and that is the difference of 2 squares. Clearly, we can see it's a difference because of the operation of subtraction, and both 9x squared and 4 are perfect squares, so this is the perfect application of the difference of 2 squares. In the first positions, we'll put the square root of 9x squared. That's going to be 3x and 3x. In the last positions, we put the square root of 4, which is 2. And one sign has to be plus and the other has to be minus, so that if you do FOIL, the outside and inside products would cancel. You see, the outside product would be negative 6x, and the inside product would be positive 6x, so those would cancel, and you'd just be left with the first product of 9x squared and the last product of negative 4, which is what we want. At this point, we set each factor equal to 0, and we solve. So we'd get 3x equal negative 2 and x equal negative 2/3 from the first factor. The second factor we would set equal to 0, and we'd get 3x equals 2 and x equals positive 2/3. So 2 roots, positive and negative 2/3. Let's take a look at the next one. This time we have x squared equals 5x. So the first thing we have to realize is our equation is not in standard form. We first want to get everything on one side equal to 0. I'm going to leave the x squared positive. I think when the squared term is positive, it's easier to factor. Students make less mistakes. So I've subtracted 5x from both sides. And now, rule number 1 says if there is a common factor, factor it out. And you have to recognize here that there's a common factor of x. And when we factor it out, that leaves us with x minus 5. As long as you have an unknown in your factor, the common factor, which is x, gets set equal to 0. So if there's a variable, you've got to set it equal to 0. And then, of course, we set x minus 5 equal to 0. And that gives us x equals 5. So 2 roots, one is 0, one is 5. Let's look at our fourth example here, and that's 2x squared equals x plus 10. Again, first step is to get it in standard form. I prefer to leave my first term positive, so I'm going to subtract x as well as 10 from both sides. And now as I look, I have 3 terms with no common factor, so I'm going to try reverse FOIL. I'll try 2x and x. Those would be my 2 values that could work, that would give a product of 2x squared. For the last slots, they have to have a product of 10, and the numbers we put in, we want the outside and inside product to have a difference of 1. So let's take a look here. I would start with 5 and 2. If you don't know the order, you can put them in and just trial and error it and see what happens. And at the beginning stages of factoring, that's an okay way to do it. So the middle term comes from the outside and inside products. Well, my outside product, 2x times 5, would be 10x. And my inside product would be from 2 times x, which is 2x. Clearly, I can see the difference of 10x and 2x is not 1x. So I have to nix that order, and I'm going to try to reverse the 5 and 2. So I'm going to put the 5 in the first slot and the 2 in the second. That means my outside product, which would be 2x times 2, would be 4x. And my inside product, which would be 5 times x, would be 5x. And 4x and 5x do have a difference of 1. The good news is I found the right combinations of numbers and terms. If I didn't find the right combination, since 5 and 2 have been tried in both orders, I would then go to try 10 and 1 in both orders. And if that didn't work, then I go back to the first positions in case there might be another combination, which that's not going to be a problem here because the only way to get 2x squared is 2x and x. So the long and short of it is I have found the right combination. I know I want the difference, which means one sign has to be positive and one is negative to have negative 10. I want the larger product, which is 5x, to be negative and the 4x to be positive so that they combine to give me negative 1x. That means I need a plus here and a minus here. At this point, I can then set each factor equal to 0 and solve. And so from the first factor, 2x would equal 5, and x would equal 5 halves. From the other factor, x would equal negative 2. All right, now the last thing we want to do is see how we can write a quadratic equation if we're given the roots. That's like starting at the end of the problem and going back to the start of the problem. Imagine the last problem we did. If I gave you x equals -2 and x equals 5/2, how I would go about solving that. So you can see I'm starting with the answers and working my way back to the equation. So how does that work? Well, I'm going to start by saying x equals -4 or x equals 7. That means the factor associated with each root I would have as x plus 4 would equal 0 and x minus 7 equals 0. You're trying to get each equation there equal to 0. At this point, all I need to do is take the product of those two factors to get the equation that would have those roots. And if I multiplied, get x squared minus 7x plus 4x minus 28 equals 0. And by combining like terms, I'd have x squared minus 3x minus 28 equals 0. Now, what about if we get a fraction? Well, there's really no difference. I'm going to set x equal to -2/3 or x equal to 6. And that means the factors would be x plus 2/3 equals 0 or x minus 6 equals 0. Now, you have to understand, we don't want to have to deal with that fraction. And besides, to be in standard form, the values of a, b, and c in the quadratic equation have to be integers, no fractions. So what I want to do is I want to clear the fraction, and I'm going to do that in this first factor by multiplying by 3. What that does is it gives me 3x plus 2 equals 0. And it's much preferable to multiply 3x plus 2 and x minus 6 than rather doing it with a fraction. So now I can see I get 3x squared minus 18x plus 2x minus 12 equals 0. And if I combine like terms, I have 3x squared minus 16x minus 12 equals 0. And now I have my quadratic equation. All right, so what are you doing? You are working to complete worksheet 4.3, which the sub should give to you. You are going to complete all of page 19. Look at the page at the bottom, 1 to 25 all. These don't require a lot of work. It's more work in your head. On side page 20, you're just doing 2 word problems, 28 and 30. You might have a little problem initially trying to solve them. I don't want you to solve them by trial and error. I want you to use algebra. So if you're stuck, look at Canvas for the setup for number 25 and see if that can help you to figure out 28 and 30. Of course, we will address questions on block day, Wednesday or Thursday. So have at it and be ready with all your factoring questions, and we will go from there. Have a great day. Thanks.